everyone. Today we're going to talk about rewriting equations and formulas. Make sure you're putting this title at the top of each page so that you know which page has which notes. This section really deals with taking an equation or taking a formula and moving things around so that it equals a certain variable. What it reminds me of is doing slope-intercept form last year, when you take the equation of a line and you move everything around so that it's y equals. This is exactly the same thing. It's just doing it in different circumstances. So when we start graphing again, we'll do that. But for now, we're going to deal with things like temperature and interest. We're going to follow the same steps. Okay, so a little bit of vocab for you. An equation that has two or more variables is called a literal equation. To rewrite a literal equation, solve for one variable in terms of the other. Right, so before we would just solve for y in terms of x, which meant everything that was not y was on the right side, and everything that was y is on the left side, right? So something like this, y equals 2x plus 1, not y is over here, just y is over here. So we wanted to get everything equal to make it look like that. So example 1 is actually just like that. It's just not for a graph. It's just for solving it in general. So it says solve the equation 2x plus 5y equals 6 for y. And that just means, and you can write this on the side as a note, get y on the left, everything else on the right. Okay. So this isn't too bad, you just have to make sure you do it in the right order, mathematically. So if we take a look at the equation we have, I'm going to rewrite it over here. You have to ask yourself, what's the first thing I want to move over, right? Because I have a couple of things on the wrong side if I only want y on that side. This is on the wrong side, and this is on the wrong side. So you may remember the first thing we need to do is get rid of the 5x. So we get rid of anything that's farther away from the y first. The 5x is farther away. So we're going to take the 5x, since it's being added, we're going to go ahead and subtract it from both sides. Okay, now you'll notice on the right, well, you'll notice on the left this cancels out. But you'll notice on the right I have 6 minus 5x. And a lot of people want to say 1 here. You cannot write 1 because the 6 does not have an x. These two things cannot be combined, and so what I'm going to do, I'm just going to write 6 minus 5x. Remember, combining like terms, you can only combine things if they both have an x, or they both have a y, or they both have a b squared. They don't. 6 is a constant, it's just a number, and the 5 has an x. Unless on the left side over here I have 2y. Okay. My next step is to get rid of the 2, and because 2 is being multiplied by y, I need to divide. So I'm going to divide the whole left side by 2 and the whole right side by 2. And you may remember, when we did this with slope-intercept, we did this, which equals 3, and then we did this. Now this is just a fraction, can't simplify, and that's okay. So I'm going to have 3 minus 5 halves x. Okay, and that's my answer. Y equals 3 minus 5 halves x. What I'd like you to do now is pause the video and try these on your own. Once you've done them, hit play and check your work. Okay, so for number 1, what I'm going to do is get y by itself. So I'm going to add x to both sides. That gives me 5y equals 10 plus x. Then I'm going to divide by 5, divide by 5, and that's going to give me y equals 2 plus x over 5. Another way you can write this is y equals 2 plus 1/5 x. Either one is fine. Number 2, I'm going to get rid of the 4x first. And while that cancels that out, it's important to remember that this stays with the 4y. So that's still there, that negative sign, and that gives me 1 minus 4x on the right. So now I need to divide by negative 4. going to give me y equals negative 1/4, and then I have a minus 4x on the top and a negative 4 on the bottom, so that cancels each other out and gives me a plus x. Okay, so that's my answer, negative 1/4 plus x. For number 3, notice that y is on the right side, and that's fine. You have a choice here. You can flip the whole thing around before you start if you want, and if you feel more comfortable with it on the left side. So I'll put the 6x plus 3y on the left and the 12 on the right. If you don't want to do that, that's fine. When you're all done, you can get something equals y instead of y equals something. It's up to you. I like to flip it. I'm just used to having it on the left. So I'm going to go ahead and subtract the 6x. That gives me 3y equals 12 minus 6x. And then I'm going to divide by 3. And that's going to give me y equals 12 divided by 3 is 4. 6 divided by 3 is 2. And there's a subtraction sign there. So it's so it's y equals 4 minus 2x. Okay, hopefully you rocked those. Let's take a look at what we're doing next. We're going to take a different formula now, so we're not dealing with x and y. This is the formula for the surface area of a cone. And surface area, the way you can kind of think of it is how much wrapping paper would you need to wrap it? That's what I always think of. It's the outside of a shape. Now this is a 3D shape, a cone, right? So it's how much material or how much space is there going around the cone and also on the base of the cone on the outside. So it's not the inside. Volume is the inside, right? Like how much water would fill it up or something. Surface area is just the space on the outside. Okay? And the formula is here in the middle. So what this says is surface area equals pi times radius squared. That should be squared. And that's plus pi times radius times slant length. And if you look over here on the right, the slant length is this right here. So it's just the length of the diagonal. Okay? And that 2 in the middle, that's a square. So we can solve the formula for the slant height L. So I'm going to go ahead and rewrite it down here. So S equals pi r squared plus pi r L. And the reason we write the L in cursive is so it doesn't look like a 1. Okay, and this makes sense. Because think about it. What is pi r squared? What's that the formula for? It's the formula for a circle, right? So this means you take the area of this circle, and then you add it to the area of this whole cone part on the top. That's the rest of the formula. All right, so we have to get L all by itself. We have to move everything else over, and we have to get L by itself. So once again, you have a choice. If you want to flip this so that L is on the left, that's fine. I'm going to go ahead and do that. So this way, I move everything else to the right. So I'm going to have pi r squared plus pi r L equals F. So once again, I'm getting L by itself. I need to move everything else over. Well, think of it like the x's and y's from before. If this were a y, right, and there's some stuff attached to it here, this was the x stuff before, right? So the first thing I have to do is actually get rid of this whole thing. And it's all together. I'm just going to subtract the whole thing. Okay? So I'm going to go ahead and do minus pi r squared minus pi r squared. And what happens is it cancels out on the left side. Oh my gosh, I'm writing so big. And so on the left side, I have pi r L, right, from over here. I brought that down. And on the right side, the same rule applies. I have an S, and I have something with an R. Those things cannot go together. So I'm just going to write S minus pi r squared. Okay? So once again, you can't do anything with that. I don't know what you would do in this case, but you can't combine them because they have different variables. One has an S, one has an R. So there's nothing you can do there. Okay. Next step. Ask yourself, what's the operation on the left over here? Because clearly, if I want to get the L by itself, right, I need to get rid of pi and r. Well, pi r L really means what? Operation-wise, it means pi times r times L. So if it's being multiplied, what do we have to do? We have to go ahead and divide, right? So it's up to you. You can do this in 2 steps. I'm actually going to show you a bit of a shortcut. You can divide both of them at the same the other. There's not really a reason to. You might as well just do them together. And here's what happens. That's done on that side, and then over here I have pi r. Now, you'll notice that this over here, these guys have the same variables. Same variable. Pi is a constant. They both have an r. And if you remember back from the exponents lesson last year, you can actually do that math. However, because this does not have the same variables, that can't be simplified. And so the easiest way to relieve this actually is just like that. So my answer, I don't have to actually do anything else at this point. It's L equals S minus pi r squared over pi r. Okay, you don't have to simplify that. That's your answer. All right, so it looks a little bit, confusing because of all the letters, but the key is just keep track of where the L is and move everything else over using the rules you already know. If it's being added, you subtract. If it's being multiplied, you divide, and so on. Okay, so what I'd like you to do is go ahead and try these three on your own. Pause the video here, and when you're done, hit play and check your answers. Alright, so let's take a look at number 4. So we have area equals base 10 pi. We're trying to get b by itself. So this one is nice because it's one step. B is being multiplied by h. You can flip this one if you want. For those of you who aren't flipping, I'm going to show you what this looks like. I want b by itself. I'm going to divide by h, and that's going to give me a over h. Okay, and that's the same thing as this. All right. Number 5, this is simple interest. This is has to do with how your money in a bank earns money, right? So interest. So it's interest equals principal, which is the money you put in there, times the rate, how much money is the bank giving you, times the time, how long is it in there. So we're trying to get p by itself. Well, what's happening on the right here? These are all being multiplied. So if I want to get p by itself, I need to divide away the other things. And just like in the previous example with the cone, I could divide by r and then by t, but I might as well just do it all together, okay? So I can actually go like that, and that gets rid of that, and that gives me I over RT equals P, and if you flipped it before you started, same thing, P equals I over RT. Alright, so those two are not bad at all. Let's look at number 6. I've got S equals 2 pi r squared plus 2 pi r h. This is a cylinder. I'm trying to get h by itself. I'm going to flip this one because I think it's kind of confusing. So I'm going to flip the whole thing around, put the right side on the left. So it's 2 pi r squared plus 2 pi r h equals s. And I'm trying to get h by itself, right? So just like the cone one, I'm going to go ahead and subtract this whole thing first. And that's going to cancel that out. On the left, I'm going to have 2 pi r h equals, the stuff on the right cannot be combined, so I write it like this. Okay, so it's 2 pi r h equals s minus 2 pi r squared h. All right, and now I need to get, sorry, my fault. I knew there was something going on weird there. There's no h. Okay, so now I need to get h by itself, and you'll notice all the stuff on the left being multiplied, so I'm going to divide. Okay, and my answer is h equals s minus 2 pi r squared over 2 pi r. Same as before, that's all I need to do. All right, so those are your answers. This is the end of the first part of this video. So if you need to go back and check anything or rewatch anything, that's fine. You do need to watch now the second video for the rest of this lesson.